Hello and welcome to the Theory of Computation lectures. In this class, we are going to solve a problem for converting an Epsilon NFA to its equivalent NFA. So let's say this is the Epsilon NFA that we have been given with, and we have to convert it to its corresponding NFA. So as before, we start by finding the Epsilon closure of each state. That means we have to find out the Epsilon closures of state A, B, C and D. So what is the Epsilon closure of state A? It will be state A itself and then state B and state D. So Epsilon closure of state A will be states A, B and D. What is the Epsilon closure of state B? It will be state B itself and state D. Okay. So Epsilon closure of state C contains only state C because there is no Epsilon transition from this state. And Epsilon closure of state D also contains only state D. So these are the Epsilon closures of states A, B, C and D. In the next step, we will find out the reachable states for every input symbol from each state. So let's create the equivalent NFA, and the state transition table will have the same states for the same input symbols. We have to find out the transitions. Let's start from state A. The Epsilon closure of this state contains states A, B and D. That means we can go to states A, B and D for free from state A. Now on input symbol 0, from state A we can go to state A itself, from state B we can go to state C, and from state D we can go to state D. And the Epsilon closures of state A contains A, B and D, state C contains C, state D contains D. So finally the current state A and the input symbol 0 in the NFA will take us to states A, B, C and D. Okay. Next let's talk about input symbol 1. So the Epsilon closure of A contains states A, B and D. On input 1, from state D we can go to state D itself, and the Epsilon closure of state D takes us to state D. So on input symbol 1 from state A we can transition to state D. From state B the Epsilon closure is states B and D. From state B the input symbol 0 takes us to state C, and from state D the input symbol 0 takes us to state D. So the Epsilon closures of these two states are states C and D. So on state B with input symbol 0 we can transition to states C and D. Again from B the Epsilon closure takes us to B and D, and from D the input symbol 1 takes us to state D. From B there is no transition on input symbol 1, and the Epsilon closure of state D is state D itself. So basically on state B with input symbol 1 we can go to state D. Now on state C the Epsilon closure takes us to state C, and on input symbol 0 from state C we can go to the null state because there is no transition, and whose Epsilon closure is again state 5. So on state C with input symbol 0 we can go to state 5. Similarly from state C with input symbol 1 we can go to state B, whose Epsilon closure is states B and D. So on state C with input symbol 1 we can go to states B and D. On state D the Epsilon closure takes us to state D. If we get input 0 at state D we are going to remain in state D, and the Epsilon closure of that is state D itself. So on state D with input symbol 0 we are going to remain in the same state. And if we look at the Epsilon closure of D, it goes to state D. Then from that state with input symbol 1 we can go to state D itself, and the Epsilon closure of state D contains the same state. So basically for input symbol 1 on state D the system transitions to state D. Okay. So the next step is to draw the state transition diagram of the NFA, making all those states final whose Epsilon closure contains the final state of the Epsilon NFA. So what is the final state of the Epsilon NFA? That is state D. And which are the states whose Epsilon closure contains that state? It is state A, B and D. So in the corresponding NFA, states A, B and D should be final states. So let's draw the state transition diagram. We start from the initial state A. On state A, if we get input 0, we can transition to state A, B, C and D. And if we get input 1, we will transition to state D only. On state B, if we get input 0, we can go to states B and D. And if we get input 1, we will go to state D. On state C, if we get input 0, we go to state 5. And if we get input 1, we go to state B and state D. On state D, if we get input 0 or input 1, we are going to remain in that state. So if you notice, we have made A, B and D as final states of the corresponding NFA, as those states contain the final state of the Epsilon NFA, in their epsilon closure. Okay, so this is the design of the NFA for the given epsilon NFA. We have converted the epsilon NFA to its equivalent NFA. So I hope you have understood the process of converting epsilon NFAs to NFAs. In the next class, we will discuss about a new topic. Thank you very much.